Hi students, in this video, we are going to discuss the last three questions from the exercise 1.1. Third question, an army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? So we are going to find the HCF. Usually when we have a function in Independence Day or Republic Day in our schools, we will be like standing in a proper line, isn't it? For those kind of parade. Here also, it has to be in the same number of columns. There should not be any mismatch. So what we do is we try to find the HCF of 616 and 32. HCF of 616 and 32. Now the greatest number is 616, that will be the divisor, that is 8. So 616 equal to, when we divide it by 32, that will be 32 ones are 32. When we subtract, it will be 9. The next is 96. Sorry, 29, and this will be 96. 9 times it is 288. When we subtract, the answer will be 8. Till you get remainder 0, we have to proceed. The quotient is 19, the divisor is 32, remainder is 8. As we are not getting the remainder 0, we need to proceed till we get remainder 0. The divisor, whatever you have in this previous step, that will be the dividend in the next step. The remainder will be the dividend. When we divide 32 by 8, it is a multiple, isn't it? 8 4s are 32 and remainder will be 0. As we are getting remainder 0, whatever the divisor you have it here, that will be the final answer. So the final answer is HCF of 616 and 32 will be 8. That is, they have to form 8 columns so that it will be uniform. Conclude in that way. So if you have any doubt, post it in the comment section. And if you want to note down, please pause the screen and note down. We'll move on to the next step. Next question. Use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. So we have to take here a as 3q plus r. The reason we have to show it is 3m or 3m plus 1. Yeah? In place of b, we have 3. So Euclid's division algorithm is a is equal to bq plus r. Isn't it? So that will be a is equal to 3q plus r, and the remainder value will be 0, 1 and 2. That is less than the divisor. Okay, so like previous question, that is in the previous video, we have expressed as multiple of 2 if it is an even number, and 2m plus 1 if it is an odd number. Yeah? Same way, we have to express here as multiple of 3. That is square of any positive integer. Okay, we have to square, and then you have to express as multiple of 3 as a whole or multiple of 3 plus 1. Let's try to show. Okay, proceeding with the first remainder, r is equal to 0. A is equal to 3q. 3q plus 0 or 3q, both means the same, isn't it? Now, when we square on both sides, as they have given square of any positive integer, a square will be 3q the whole square, that is 9q square. We have to express as a multiple of 3. Ne? So we can take 3 as common. So that will be 3q square. And now we are assuming this 3q square as m. Let 3q square is equal to m. So therefore, we are getting 3m, that is multiple of 3. We have expressed one part of the answer as multiple of 3. The next is r is equal to 1, that is a is equal to 3q plus 1. We have to square on both sides, isn't it? So a square is equal to, you are not supposed to whole square separately. We have to take as a whole square. 3q plus 1 the whole square. We have to follow a plus b the whole square form. So a is equal to 9q square plus 6q plus 1. So this one we cannot simplify further. So we'll try to take 3 as common from these two terms. So when we take that as 3, the terms will be 3q square plus 2q plus 1. Now we are assuming this 3q square plus 2q as m, 3m plus 1. Let 3q square is equal plus 2q is equal to m. We have expressed as 3m plus 1 form. And lastly, r is equal to 2, a is equal to 3q plus 2. When we square on both sides, it will be 3q plus 2 the whole square, that is 9q square plus 12q plus 4. 4, we can either write it as a 4 simply, or we can write that as 3 plus 1. Isn't it? Both means the same. Now, we are going to take 3 from these 3 terms. That will be 3 into 3q square plus 4q plus 1. The plus 1, let it be as it is. And now we are going to assume that as m. So 3m plus 1. Let 3q square plus 4q plus 1 be m. Therefore, we have expressed as 3m plus 1. So from these 3 parts, let this be first equation, let this be second equation, let this be third equation. So from 1, 2 and 3, we have expressed that square of any positive integer as a multiple of 3 or multiple of 3 plus 1. Okay, so if you want to note down, pause the screen and note down. We'll move on to the next question.